All right, so 5, 6, part 1, beginning of inverses. You can't do 2, 3, or 4 without knowing what inverses swap. Inverses swap domain and range. That's one way of saying it. Or you can say swap x and y. And like, that's fine. Most things we do involve x and y, but the real thing is they swap input and output, all right? Because when you talk about input, you're talking about domain. When you talk about input, you're talking about x, and vice versa. So the first one or the last one are really the best definitions. They really are. All right, so number 3 on this one's probably, at least in my mind, the hardest one. So I have a function that has order pairs 1, 3, 7, 4, 8, 6, 9, y. What restrictions are there on the value of y so the inverse of the function is also a function? So in your notes, you learned that a 1-to-1 function passes what we call the horizontal line test. And specifically, neither x or y can repeat, all right? So let's go ahead and talk about our inverse here. We'll just call it f to the negative first of x. And it would have the following ordered pairs. We would swap x and y. And that's what I'm doing. I'm swapping x and y. So that's what it would look like, all right? The x's cannot repeat, so y is going to be anything but a 6, a 4, and a 3. You see that? Because if I make this a 3, the x's have repeated. If I make this a 4, I'm sorry, my cursor's in the way, the x's are repeated. If I make it a 6, the x's have repeated. So I can be anything but these existing values. So I can be all values of y such that y is not, see if I can pull that symbol up. Three, 4, or 6. I can be anything else. 2 and 4, I'm leaving for y'all. Draw the function, its inverse, and the line of symmetry. List the domain and range of both the function and its inverse. Restrict the domain if necessary for the function to become 1-to-1. As much as I don't like, I know as a teacher that I have to do number 5 because maybe half of you can't graph y equals mx plus b, and you just have no idea how sad that is. Like, that is the word pathetic. That's what it is. I'm not trying to knock you, but you've been doing this since 8th grade, man. It's really disheartening. I don't understand your issue. You have a y-intercept at -3, 1, 2, 3, and your slope is to rise 4 and run 1. So there is the original function. This is g of x. And g of x had the points 0, -4, and it had the point 1, 1. Sorry, not 0, -4, 0, -3, and then 1, 1. So its inverse, denoted g to the negative first of x, read the inverse of g of x, is going to swap x and y. It's going to contain -3, 0, and this is still going to be 1, 1. So I'm going to have to go back 3, up nothing, still contain 1, 1. This would be the inverse function. And this is g to the negative first of x. The line of symmetry talks about the line of symmetry. The LOS is y equals x. Y equals x, which again, some of y'all would struggle with, passes through the origin, has a slope of 1. I'm going to dash it. And that's what things are reflected about. All right. Now, The reason I didn't have to restrict the domain is because the original function was 1 to 1. I could have drawn a vertical line and been okay. I don't want to do all of these, but here's 7. 2 times x plus 3 squared minus 2. And this one is going to require a domain restriction. So we have a left 3. We've been over and over that. Left 3 down to, I don't know why you guys aren't letting this click. Then we have our initial slope of rise 2 run 1. And that's what it looks like. Now here's the issue. It failed the horizontal line test. Okay, so here's how we fix this. And I don't know how well I would have talked about this yesterday in Algebra 2, but we keep the interval on which the graph is increasing. We keep the increasing side of the graph, because that's how someone who's smarter than you or I decided to do it, okay? But that's what we're going to do. We're going to keep the increasing side of the graph. Okay, so the increasing side of the graph was this guy. So my domain here is that I'm everything to the right of -3. So -3 to infinity, or if you like your set builder, all values of x such that x is greater than or equal to -3. You know, and eventually you'll catch on to those little things. See that +3 became -3 and so forth. Now, I contain the points -3, -2, and I contain the other point here being -2, 0. My inverse is going to contain what happens when I swap these points. I've got to reverse these things. My inverse is going to contain -2, -3, should be right there. And it's going to contain 0, -2, which would be right there. And it would look like this. My line of symmetry, remember the line of symmetry is always y equals x. And this guy is f to the -1st of x, and this guy is f of x. There you go. What else were we supposed to do in the instruction set? Make sure I read them. Oh, I didn't even do that on number 5, did I? Talked about the domain and range of the given function and its inverse. So let's talk about the domain of the original function, f of x. Its domain, it was a line. It was this guy right here, was -infinity to infinity. Its range was also -infinity to infinity. Its inverse, called f to the -1st of x, happened to also be a line that ran left and right forever. So back to this guy. All right, so when I first did this, you know, I restricted the domain. So talk about f of x. Its domain was -3 to infinity. It ran to the right of -3, but it also ran up forever. Its range was -infinity. Sorry, messed that up pretty bad. Its range was -3 to infinity. Sorry, -2 to infinity. Or all values of y such that y is greater than or equal to -2, whatever floats your boat. Its inverse, its domain, if you look at it, technically starts at 2. Technically, it does start at -2 because we swapped domain and range. So -2 to infinity. And its range happens to be the old guy's domain. Sorry, I just got like really tired. This needs to be a bracket, that needs to be a bracket. All right, been a long day. Kids just left too and they exhaust me. I'll leave 9.